Welcome to The Deep Dive, the show that's your shortcut to being truly well-informed. Today, we're plunging into a topic that's, well, it's everywhere. It's transforming our world incredibly fast, artificial intelligence. You hear all these terms flying around: AI, machine learning, deep learning, generative AI. Sometimes they're used, all jumbled together, and it can feel a bit like trying to drink from a fire hose. So our mission today, let's cut through that noise. Let's demystify these core ideas. We want to give you a really clear understanding of what they actually mean, how they fit together, and crucially, why they matter to you. Think of it as a guided tour unpacking each layer of this tech, making it clear, making it accessible.
That's exactly right. I mean, the buzz around AI is huge and definitely for good reason. But yeah, you're spot on. Lots of people use these terms like they're synonyms, when actually they represent distinct layers, all connected but distinct, inside this really dynamic field. I like to think of it almost like sophisticated Russian nesting dolls. Each idea fits inside the last one, getting more specialized, more capable as you go deeper. By the end of this, you'll have that foundational grasp. Those distinctions will be clear. It'll help you make sense of the AI you're already using every day.
Oh, I love that nesting doll analogy. That really clicks visualizing the structure. Okay, so let's unpack this. Let's follow a clear roadmap, starting with the biggest one, the outermost doll, artificial intelligence itself. So to kick us off, what does it actually mean for a system to be quote-unquote intelligent here? What's the basic idea?
Right. At its core, artificial intelligence, AI, it refers to systems built to show, well, human-like intelligence. So that means capabilities like perception, understanding what a camera sees or a microphone hears. They can do reasoning, drawing conclusions from information. And critically, they can learn. They're also about problem solving and making decisions. Think of it like a machine simulating those cognitive things we associate with our own minds. At its most basic level, maybe an early AI system, it might just be programmed with simple rules. If this happens, then do that. It's about following predefined logic to hit a goal.
Okay, that makes sense for like foundational AI, simple rules. But
Yeah.
here's where it gets fuzzy for a lot of us because you hear AI and machine learning used almost interchangeably. So if AI is the big umbrella, what's machine learning, ML? How does it change that if-then idea you just mentioned?
Yeah, that's a really crucial distinction. Machine learning, or ML, it's actually a subset of AI. It's a specific way of achieving that artificial intelligence. And the big idea with ML, the kind of revolutionary part, is instead of us programming every single rule for every situation, those if-thens, we build systems methods for machines to learn those rules themselves from data. The key thing is, an ML system uses data to get better, to improve its performance. And it makes predictions or classifications based on that data. Critically, without us explicitly programming every single rule. It's more about letting the model decide, finding patterns in the data itself.
Okay, let me see if I follow. So instead of telling a system, okay, a dog has 4 legs, fur, a tail, it barks. You just show it thousands of pictures of dogs.
Yeah.
And it just figures out dogness itself.
Exactly. That's a perfect way to put it. A traditional AI might get that explicit checklist, like you said. But in an ML system, it gets shown thousands, maybe millions of images, dogs, cats, birds, whatever. And just by looking at all that data, it starts to learn the underlying patterns. What makes a dog different from a cat? It's not told the rules, it infers them. We sometimes visualize this. You might see graphs showing regression, like drawing a line to predict house prices from past data, or classification where it groups things into clusters like here are the dog pictures, here are the cat pictures. Learning from examples, not instructions, that's what makes ML so powerful.
That really is a huge shift from rigid rules to like dynamic learning. It's genuinely fascinating. Okay, so if ML helps machines learn from data, what's the next step? Is there an even deeper way they can learn? The next doll inside ML?
Absolutely. And that brings us straight to deep learning, DL, which is, you guessed it, a subset of machine learning. What really sets deep learning apart is its structure, how it processes information. It's inspired, actually, by the human brain. It uses what we call neural networks. These are networks of interconnected nodes, neurons, and synapses. They're mathematical concepts, but they mimic biology. Information flows from an input, through potentially many hidden layers, to an output. Think of each neuron in its hidden layers processing a piece of the puzzle, and the synapses are the connections, adjusting their strength based on the data they see. It's like information getting filtered and transformed layer by layer, with each layer pulling out more complex features.
Neurons, synapses, hidden layers. Wow, okay. That definitely sounds more complex, more layered than maybe traditional ML. So what kinds of patterns can deep learning pick up on that maybe simpler ML would miss?
Well, DL can identify much more complex, subtle, and nuanced patterns. Think about it. Maybe basic ML can classify dog, but deep learning might be able to identify specific breeds, or even guess a dog's mood from tiny facial cues in a photo, or, going further, even generate a realistic image of a dog that never actually existed. But this power isn't free. Deep learning usually needs lots of data, really vast amounts to train those complex networks effectively, and it demands serious computational muscle, a lot of CPU or GPU power, especially for the training phase. That's why, the big jumps in computing power recently have really gone hand in hand with the rise of deep learning.
Right, the hardware had to catch up to the ideas. So where are we bumping into deep learning in daily life? Any common examples?
Oh, constantly. You interact with it all the time, probably without thinking about it. Computer vision is a huge one. Things like facial recognition on your phone, that's DL. Object detection in self-driving cars, identifying pedestrians, other cars, signs. DL. Even fancy photo filters on social media often use it. Natural language translation, when you translate text or speech instantly online. That relies heavily on these deep neural networks. And yeah, self-driving cars are a massive application, using DL to perceive the world around them and make split-second decisions. What's really cool is how dynamic they are. You feed them more data, and the connections inside adjust. They get stronger or weaker. They learn new patterns, refine their understanding, all without a human explicitly reprogramming them. They adapt.
It's incredible that continuous learning and adapting, it's almost alive in a way. Okay, that leads us perfectly to what feels like the absolute cutting edge right now, generative AI. How does this build on deep learning? What makes it such a leap beyond just recognizing things?
Yeah, generative AI or Gen AI, it is definitely a subset of deep learning, you're right. But it takes things to a whole different level, a really remarkable level. Instead of just analyzing or classifying or predicting based on data that already exists, Gen AI is focused on creating something entirely new based on what it's learned. It moves beyond just understanding the world to actually contributing to it, often in ways that are quite surprising.
So it's not just pattern recognition anymore, it's actual creation, like an artist or a writer might create.
Precisely. Synthesis is the key word. Generative AI often uses these huge models called foundational models, or FMs. They're foundational because they're these massive neural networks trained on just unbelievable amounts of diverse data, like huge chunks of the internet, massive libraries of images and text. This broad training gives them a really general understanding of patterns in language, images, code, you name it. The process usually involves feeding vast amounts of unlabeled data into these FMs. And then they can adapt to generate all sorts of outputs. We see it generating realistic text, drafting emails, writing articles, even creative fiction, summarization, taking long documents and giving you the key points, extraction, pulling specific info out of text, creating completely unique images from just a text description, building sophisticated chatbot responses that feel eerily human, providing detailed answers in Q&A systems. So yeah, if AI helps us act, ML helps classify, DL helps make complex decisions based on learning, then Gen AI lets us sometimes be creative, composing music, writing poems, designing things.
Wow. To get that level of creativity, especially with language, you hear a lot about transformer models and LLMs, large language models. What's special about those? What makes them so good at generating coherent, context-aware text?
That's a great question. One of the absolute biggest breakthroughs that enable this kind of sophisticated generative AI, particularly for language, is the transformer model. This is the architecture, the blueprint behind many of the best large language models, LLMs you use today, like the ones powering advanced chatbots. The key innovation of the transformer is something called the attention mechanism. Instead of processing words just one after another, in sequence, like older models did, it could look at the entire sentence or even bigger blocks of text all at once. And this lets it figure out the importance of words relative to each other within the context of the whole piece. It understands how words relate, even if they're far apart in the text. That's crucial for grasping meaning and generating language that sounds natural and relevant. Plus, they're surprisingly efficient. They're generally fast and more efficient than older text processing methods, which means less processing time. That makes these huge models practical to actually build and run.
That attention thing sounds like a real game changer, understanding the whole context, not just words in a line. Okay, but what about the really wild stuff? The AI that mixes images, audio, text, like you type a description and it makes video. How do models handle that kind of mix?
Now you're talking about multimodal models. And yeah, they really feel like the next frontier. A key thing here is, unlike older models that usually specialize in one type of input, just text or just images, these multimodal systems are not stuck with a single input type, and they don't just produce one single output type either. They're incredibly flexible. They can take a mix of audio, image, and text as input. And then they can produce a mix of output too. Imagine feeding it, say, a photo of a sunset, a sound clip of waves crashing, and the text prompt, a peaceful beach scene at dusk. And it generates a short video, maybe with some fitting background music and a little bit of generated narration. It's combining all those inputs. Under the hood, they usually have two main parts: multimodal embedding models, which figure out how to understand various inputs by translating different data types into a common language the AI can understand, and then multimodal generative models, which use that combined understanding to actually create new content. It's kind of like teaching an AI to see, hear, and read all at once, and then asking it to make something new using all those senses.
Wow, okay, so we've gone from simple rules to learning from data to deep pattern finding and now creating new stuff across different media.
Yeah.
It's genuinely mind-boggling when you trace that progression. So we've explored what AI is and what it does, but for someone maybe thinking, okay, how do these things actually get built? What are the core pieces needed to bring an AI system to life?
Right, connecting it back to how these systems are actually engineered and deployed.
Yeah.
We can think about it about four fundamental layers. Each one is critical. First, and you absolutely cannot skip this, is the data layer. And I really can't stress this enough. You need lots of it.
Right.
Data is the absolute lifeblood, the fuel for any modern AI, especially ML and DL. And it's not just about quantity, right? It needs to be good quality data, clean, relevant, properly structured. Think of data scientists almost like, I don't know, digital archaeologists, carefully gathering and preparing that raw material.
Okay, so data first. Garbage in, garbage out, as they say, right? The quality there is key.
Exactly. Then, building on that foundation of data, you have the ML framework layer. This is where you start to understand the use cases and choose the right tools through software libraries to actually build your models. You hear names like TensorFlow, PyTorch maybe. These are popular frameworks. Picking the right one depends on the problem you're solving, the kind of model you need, your computing setup. It's like choosing your workbench and your specific power tools.
Got it. So you've got the data, you've picked your tools. What's next?
Then comes the model layer itself.
Yeah.
This is the engine room, really. This is where you train it, set the parameters, define the functions. Training means feeding that prepared data through your chosen framework. The model learns, it adjusts its internal settings. Those are the parameters, trying to get better at the task, minimize errors, make accurate predictions. It's often an iterative process, like studying for a test, right? You practice, you see what you got wrong, you adjust your understanding. This is where the learning really happens, guided by mathematical functions that measure how well it's doing.
Okay, the learning engine. And then finally, after all that hard work building and training, how do we, the users, actually get to use it?
That's the final piece, the app layer. This is where you serve the user. It's about taking that trained AI model and integrating it into something people can actually interact with. It could be an app on your phone, a feature baked into business software, a voice assistant you talk to, or maybe an API that other developers can plug into. This layer makes all that underlying complexity useful and hopefully seamless for you, the person using it.
This has been such a helpful journey, really dissecting these layers of AI. So wrapping this up a bit, what does understanding all this mean for us, for the listeners, as we just try to navigate this world that's getting more AI-driven every day? Why does knowing these distinctions actually matter?
Yeah, I think understanding these different layers, their capabilities, it really empowers you. It helps you see past the hype, past the marketing buzzwords. You can start to appreciate the sheer complexity and, honestly, the ingenuity that goes into building these systems. Whether it's an AI recommending a movie, drafting an email for you, a car driving itself, or even an AI creating music. Knowing the difference between ML, DL, Gen AI helps you be a more, let's say, discerning user, a more informed user. You can ask better questions about the tools you use, evaluate them more critically. You get a better sense of both the amazing potential and the very real limitations.
We've definitely taken quite a journey from just the basic idea of systems that can perceive and reason all the way to this complex, nuanced creativity of multimodal generative AI. We've uncovered the power, the potential packed inside each of those nesting dolls. It's really something to see how each level builds on the last.
It really is. And while the tech underneath is incredibly sophisticated, the core concepts aren't magic. Learning from data, finding patterns, making decisions, even creating new things. These ideas are weaving themselves deeper into our lives, often in ways we barely notice. Having this understanding helps, I think, demystify it all.
Yeah, this deep dive definitely shows AI isn't just one thing. It's not a monolith. It's this whole spectrum of capabilities, each level building on the last, leading to the sometimes mind-blowing AI we see today.
And, this really raises a huge question for all of us looking forward. As AI keeps evolving, which it's doing incredibly fast, learning from more and more data, generating things we couldn't imagine before, what new kinds of intelligence are going to emerge? Things that might even challenge how we define intelligence right now. And maybe more importantly, how will we as humans adapt? How will we collaborate with and how will we steer these increasingly sophisticated systems in the future?
That is a really powerful thought to leave with, something to chew on as you go about your day. Maybe you'll see the AI around you with completely new eyes now. Thank you so much for joining us for this deep dive.